2.2, we're going to talk about characteristics of quadratic functions. All right, so quadratic functions we talked about in chapter 3 where we solved them. So quadratic functions are x squared. So we can see them as either where we have an x squared term or if we have like x in the parentheses squared, something like this. We're going to be graphing them in chapter 2. So our graphs of quadratic functions are going to look like parabolas. So it's going to have a U shape. So we can write quadratic functions in vertex form. Vertex form is this. We have y is equal to a times x minus h squared plus k. Where the h and k in our vertex are the h and k, well, the h and k in our vertex form are the h and k in our vertex, which is the point at either the tippy top of the vertex or the very bottom of the parabola. So this point down here would be our vertex, and that is the point h comma k. So it's like an xy coordinate, but it's a special point because it's the vertex, so they use h and k here. Same thing if we had a parabola that opened down, bless you, the vertex would be at the very top, which would be that hk. So it just depends on which way our parabola opens, but that point, that key point, is our vertex. So we have to know vertex form, that equation there. We also have to know how to find our vertex. So we have another formula for that. To find our vertex, to find the h in the vertex, we use negative b over 2a. So it's important that we know this little formula too. And just like we had a, b, and c using our quadratic formula, we find our a, b, and c the same way here. So what would our a be? 1, the number in front, which would be 1. What's our b? Negative 12, and c? 18. So let's plug in a and b. So we have negative 12 over 2 times a, which is 1. So negative 12 would turn into a positive 12 over 2, which simplifies to 6. So that is our h in our vertex. For our vertex, it's h comma k. So our first number is 6. Any questions so far? Next, we're going to find the k, the second number in our vertex. So to find k, we plug in h into the x's. So I'm going to take 6 and plug it into the x's in my original equation. So I have 6 squared minus 12 times 6 plus 18. What's 6 squared? 36. And 12 times 6? 72. Plus 18. What's 36 minus 72? Negative 36. And negative 36 plus 18? Negative 18. So the k in our vertex is negative 18. So this is our vertex. Once we have our vertex, we can plug it into vertex form. So our vertex form is that equation at the top. We have y is equal to a times x minus h squared plus k. So we're going to plug in our h, k, and a. A comes from our original equation. What's our a? 1. So I'd have y is equal to 1 times, do I need the 1 there if I'm multiplying it? Nope. If it was any other number other than 1, you'd write it, but since it's just 1 and we're multiplying, we don't need to put it. So x minus, what's our h? 6. So x minus h squared, what would come next? Minus 18, perfect. So this would be our vertex form. So we identified the vertex and plugged it in to find our vertex form. Notice how the h changes the sign. So in our vertex, it's a positive 6, but when we plug it into the parentheses, our formula is minus h, so it changes to minus 6. So we always flip the sign of the h. So change the sign of h. But the k keeps the same sign. Yeah. So yeah, so you need to know your formula to find the h, so this formula, and then to find k, you plug it into the x's. So let's look at 13. So we're doing the same thing. We want to find vertex form and find the vertex. So to find our vertex, we're going to start by finding the h. Our h is negative b over 2a. So you have to know this formula. Well, what's our a? 1. What's our b? Negative 8 and c? 18. So let's plug in a and b. So we have negative 8 over 2 times 1. So that would be positive 8 over 2, which simplifies to 4. So in our vertex, the first number is going to be 4. How do I find the second number in the vertex? We have to plug 4 into the x's. So I have 4 squared minus 8 times 4 plus 18. So 16 minus, what's 8 times 4? 32 plus 18. 16 minus 32. Negative 16 plus 18. 2. So what's our k? 2. Second number in our vertex is 2. So this is our vertex. Now let's plug it into vertex form. Our vertex form formula is y equals a times x minus h squared plus k. So anyone want to give it a shot? What would our vertex formula be? Y equals, John.
Y equals 1 times x plus 4 squared
plus 2. Perfect. Do I need the 1 out front if I'm multiplying by 1? No. We don't need it there. So this would be our vertex form. Perfect. Notice how we changed the sign of the h, but the k kept the same sign. So it turns into x minus 4 squared plus 2. Great job. All right, let's go to the next page. This question doesn't ask for it, but let's find our axis of symmetry. So our axis of symmetry is x is equal to h. What's our h here?
4.
4. So x is equal to 4. So once you have the vertex, there's no math for your axis of symmetry. It's just whatever your h value is.
So it's the help to deal with this just like you do for the axis of symmetry, just do the what's h form?
So it's just x is equal to whatever your h is. So we use the same h in our vertex. All right, so we're going to be talking about our properties of parabolas. So we know that our vertex comes from either the very top part of our parabola or the very bottom. So that key point that we have our h comma k is our vertex. If our parabola was to open downwards, our vertex is at the very top. But again, that's our hk. And then we also have this line that goes down the middle that's kind of not really part of our graph. It's like a separate part. It's called the axis of symmetry. So our graph is symmetrical about the axis of symmetry. So you'll see when I graph it, I make the axis of symmetry a dotted line just because it's not really part of our parabola, but it helps to see our shape. We have the same exact shape on the right side and on the left. It is symmetrical. It's a mirror image of each other. We have an equation, I guess you could call it a formula, but it's an equation for your axis of symmetry. That is x is equal to h. So that's our axis of symmetry formula. So it's just x is equal to, because it's a line, you got to say x is equal to, and it's h. Whatever our h is in our vertex, it's the same number that's going to be in our axis of symmetry. All right. Going to the next page, it says example 1. We need to graph, label the vertex, and the axis of symmetry. So when we have vertex form, first thing we want to do is identify our vertex. So remember, our vertex is what we're adding on the inside of the parentheses and what we're adding on the outside. But we always have to change the sign of h. Perfect. -3, 4 would be our vertex. So let's go ahead and graph that. I'm going to draw my graph over here. So I'm going to go to the left, -3, and up 4. Next, let's find our axis of symmetry.
Why do you switch the sign?
That's just the formula because it's x minus h inside the parentheses. So when it's plus, it would be like minus -3. So you always change the sign of the h, the first number. What would our axis of symmetry be? Just -3? X equals -3. Don't forget the x equals because it's a line. So you need the x equals there. Now our axis of symmetry is always a vertical line that goes right through our vertex. So our parabola is going to be symmetrical about the axis of symmetry. It's going to have the same picture on the left and on the right side. So to find other points on our graph to figure out what shape our parabola has, the next thing we want to do is plug in a number that's close to the axis of symmetry into x to find values for y. So I'm going to write that down. So we want to plug in a number for x to find y for additional points. So that number is going to be x comma y. That'll be a point on our graph. And a helpful hint is to pick a number close to the axis of symmetry. I'm going to call it AOS for short, axis of symmetry. So what number should we pick to plug into x? What's number close to our axis of symmetry? Perfect. Our axis of symmetry is -3, so let's plug in -2. So I'm going to pick -2 to plug in. So I'm plugging it into the x in my original equation. So I have -2 times -2 plus 3 squared plus 4. Because our graph isn't just one point, it's a parabola. It's got to have that U shape. So to find how our U shape goes, how narrow or how wide it's going to be, we need to figure out another point on our graph. So every parabola is going to need 3 points. So to find another point, we're going to plug in a number that's close to our axis of symmetry. So we picked -2 because our axis of symmetry is -3. So a number close to that would be -2. So let's solve. Make sure you follow your order of operations. PEMDAS. What does the P in PEMDAS stand for? Parentheses. So we're going to do inside the parentheses first. -2 plus 3 is 1. Good job. What does the E in PEMDAS stand for? Exponent. What's 1 squared? 1. So we have 2 times 1 plus 4. What does the M in PEMDAS stand for? Multiplication. So -2 times 1 would be -2. And -2 plus 4? 2. So my point is -2, comma 2. So I'm going to go to my graph. Go to the left to -2 and up 2. So everybody understands how we got that point. Right, now we said our parabola needs 3 points. So I have 2 so far, our vertex and 1 other. I'm going to use the axis of symmetry to help me find my other point. You can plug in another number, plug in -4 and evaluate it if you want and find another point. But we know that our axis of symmetry is a mirror. So if I have a point that's 1 space away from my axis of symmetry on the right side, I'm going to have another point that's the same y, but 1 space away on the left side too. Whatever we have on the right side, you are going to have the same thing on the left. Your axis of symmetry is a mirror. So we got the same thing on both sides. Once we have our 3 points, we can draw our parabola. So our parabola is either going to be an upside down U or a U. Here, is it a U or upside down U? Upside down U. A sad face. That would be our parabola. One way that we can tell if it's going to be, I guess you could say, a happy face, a U or an upside down U, a sad face, is the A, which we'll talk about this. There's a slide for it on the next couple pages. If your A is positive, it's a happy face. If your A is negative, it's an upside down U or a sad face. So here our A is negative, our A is -2, so it's an upside down parabola. The vertex comes from what you're adding inside and outside of the original equation. But you always flip the sign of your H. So that's why it turns into -3 and 4. So what you're adding on the inside and what you're adding on the outside. The number that you're multiplying out front has nothing to do with the vertex. So when it's in vertex form, you can clearly just look at the equation and see what your vertex is. For questions like this, I'm going to write down the steps on what we need to do to graph when we have vertex form. We're also going to be graphing given standard form. So just to kind of tell the difference and know what to do next, I'm going to write down the steps. So for vertex form. So if you want to, you can either write this down or when I'm done, take a picture of it, but I would definitely make sure you have this in your notes. So step 1 is find the vertex and graph it. Step 2, find the axis of symmetry, which I'm going to call AOS. I'll say find the axis of symmetry and graph it. Step 3, pick a number close to the axis of symmetry to plug into x. Solve for y. So that'll give you your point x comma y. And graph it. And then step 4, graph the mirror of that point. So these are the 4 steps that you need to graph when given vertex form. We have 2 different forms, vertex form, which is the first one here. And then standard form is what we're used to when our x squared comes first plus x plus our constant. So this would be standard form. So yesterday we practiced going from standard form and putting it into vertex form. You probably won't be asked to take it from vertex form and put it into standard form, but you could always just like FOIL the parentheses and then distribute. I think vertex form may be a little bit easier to graph just because we can clearly identify our vertex as the h and k. In standard form, we have to use our formula to find the vertex. So here we have our properties of our graphs. So we can either have a parabola that opens upward or opens downward. The a, so the coefficient in front of the x squared, that a, tells us if our graph is going to open up or down. If a is positive, our graph opens up, like a smiley face. If a is negative, our graph opens down, like a sad face. So if our leading coefficient is positive or negative, that tells us which way our graph is going to open. And then again, we use our formula negative b over 2a to find our axis of symmetry and to find the vertex. And then also whatever our c is, when we're in standard form, c is our y-intercept. So that's where we cross the y-axis. So we could plug in a number to find a point on our graph, just like we did in vertex form, or we could just see what that value c is, and we know that that's where we cross the y-axis. So in example 2, we want to label the vertex and axis of symmetry and graph. So in standard form, we want to use our formula negative b over 2a to find what our h is. So what's my a here? And what's b? And c? 1. Awesome. So let's plug it in. I have negative 6 over 2 times 3. So that would be positive 6 over 6, which turns into 1. So 1 is my h. So in my vertex, the first number is 1. How do I find the second number in the vertex?
Plug it in.
Plug it in. Perfect. So we're going to plug it into the x's. So you have 3 times 1 squared minus 6 times 1 plus 1. Make sure you follow your order of operations. So 1 squared is 1, and 3 times 1? 3. And 6 times 1? 6. We have 3 minus 6 plus 1. What's 3 minus 6? Negative 3 plus 1? Negative 2. So the second number in our vertex is negative 2. So let's go ahead and graph our vertex. So I'm going to go to the right to positive 1 and down 2. Put my point there. Next, let's find our axis of symmetry. What would our axis of symmetry be? 1. Awesome. It's whatever our h is. So it's x is equal to 1. Our axis of symmetry is the dotted line that goes right through our vertex. Now we need another point on our graph. Just like in vertex form, we could plug in a number that's close to the axis of symmetry and find another point. We could also use our C as the y-intercept. That is where we cross the y-axis. What's C? What is C? 1. So I'm going to cross the y-axis at 1. Awesome. Since we have a point on the left side of the graph, we know that we're going to have that same point on the right side. So since that point is 1 space away on the left, I'm going to have the same point 1 space away on the right. Once we have our 3 points, we can draw our parabola. So parabola is a U shape. So we have our vertex, the axis of symmetry, and the graph. All right, so yesterday I gave you steps for when we have vertex form. I'm going to give you the same steps when we have standard form. So to graph, when you're given standard form, first thing you want to do is use negative b over 2a to find h. What do I do to find the k? Plug it back in. Perfect. Plug in h to the x's to find k. So we just take that number and plug it back in to find k. Step 3 is we're going to plot the vertex, which is h comma k, and our axis of symmetry, which is x is equal to h. Step 4 is that we need another point, so we're going to plot the y-intercept, which is c. And then step 5 is to plot the mirror of C. So let's start with number 1. So this is in vertex form, so we can clearly identify our vertex. Remember, our vertex is what we're adding inside and what we're adding outside, but we always change the sign of h. So what would my vertex be here? What am I adding inside? 1, but we would change that to be negative 1 because we changed the sign of h. What am I adding on the outside? Am I adding anything on the outside? Nope. So negative 1 comma 0. Now what would our axis of symmetry be? Just negative 1? X is equal to negative 1. Don't forget the x is equal to. So we can graph that. I'm going to go to the left, negative 1, and stay on 0, and then put my axis of symmetry right through the middle. Bless you. All right, what else do I need here? I need another point. So let's plug in a number that's close to our axis of symmetry. What's a number that's close to negative 1? Negative 2 works. What's another number that's close to negative 1? 0. I would pick 0 just because the math's going to be easier, but if you want to pick -2, that's fine. Let's do -2. You could also pick +1, too. The farther you get from your axis of symmetry, the bigger your numbers are going to end up. So I would just make sure you stick with something close to the axis of symmetry. So let's plug in -2. So that's going to be the first number in my point. I'm going to evaluate it when I plug it into the question to find out what the second number is. So I have -3 times -2 plus 1 squared. Make sure you follow your order of operations. Got to do the parentheses first. What's -2 plus 1? -1 and -1 squared. +1. -3 times +1. -3. So I plugged in -2 and got -3. So I'm going to go to my graph, go to the left to -2 and down 3. How can I tell where I'm going to have another point on my graph? Mirror it. So I have a point that's one space away on the left side. I'm going to have that same point that's one space away on the right side. Once you have your 3 points, you can draw your parabola. Our parabola opens down here, which we knew it was going to open down before we even graphed it because our A was negative. So you can always check your work that way. Once you plug in your points and you see which way your parabola opens after you graph it, just double check with the A. Our A said that we were going to open it down, and it opens down. So let's look at number 3. So here we have standard form. Standard form, we have to find our vertex first. So our little formula to find our vertex is -b over 2a. Well, what's our A? 1. What's our B? And C? -1. So let's plug those in. So I have -2 over 2 times 1. So -2 over 2, which simplifies to what? -1. So in my vertex, the first number is -1. How do I find the second number? Plug it in. We're going to take -1 and plug it into the x's. So I have -1 squared plus 2 times -1 minus 1. Everybody with me so far? All right, so -1 squared is 1. 2 times -1 would be -2 minus 1. 1 minus 2 is -1. And -1 minus 1? -2. So let's graph our vertex. I'm going to go to the left, -1, and down, -2. What's our axis of symmetry? X equals -1. Perfect. It's the same number as our H, the first number in a vertex. So I'm going to put a dotted line right through -1. Everybody good so far? All right, now I need 2 more points on my graph. How can I find another point? The y-intercept. What's our y-intercept? Careful. We're on number 3. -1. Our y-intercept is the C. That is where we cross the y-axis. So we cross the y-axis at -1. So I got 2 points. Where's my third point going to be? The mirror of it. So if I'm one space away from my axis of symmetry on the right, I have to be one space away on the left too. And then I can draw my parabola. So next we're going to talk about some characteristics of our graphs. When our graph opens up, is our vertex at the highest point or the lowest point of the graph? The lowest point. So that would be a minimum. So when our graph opens up, we have a minimum. And our minimum value is whatever the y value is. So here it says f of negative b over 2a. That is just our y value, or our k, I'll call it. The y from the vertex, which is the k. So the minimum value is your k. The domain is always, always, always all real numbers. Our range, since our graph is opening up, we're talking about y values that are greater than or equal to whatever your k is. So again, we just use that same number that our k is. Bless you. And then if your graph's opening up still, we are decreasing on the left side and increasing on the right side. So now if our graph is opening down, our vertex is it at the highest point of the graph or the lowest point? Highest, so it would be a maximum value. The maximum value is whatever our k value is. Domain, again, is always all real numbers. The range, since our graph is opening down, we're talking about y values that are less than or equal to whatever our k value is. And then here we're increasing to the left and decreasing to the right. So there's a couple questions from the homework that's going to ask you for all of these things. I would recommend using the notes to help you. In example 3, we've defined the minimum or maximum value, describe the domain and range of the function, and where the function's increasing and decreasing. So it's not asking for us to graph it, but it helps to have an idea of what our graph looks like. Let's find the vertex because we need to know what our k is if we're going to find the maximum and minimum value. But first, let's determine, is our graph going to open up or open down? And how do we know? How do you know that it's going to open up? Because A is positive. A is 1/2. It is positive, so we know that our graph is going to open up. So is the vertex at the highest point or the lowest point? Lowest. So is it going to have a max or min? A minimum. So we're going to have a minimum. Now we need to find our minimum value. Our minimum value is whatever the k is. So we want to find our k. We got to find the vertex, which is hk. So to find our vertex, we need to use our formula negative b over 2a. Well, what's our a? 1/2. And what's our b? Negative 2. So let's plug it in. So I have negative 2 over 1/2. Oh no, what do I do when I have a fraction and a fraction? Keep, change, flip. Keep the top. I'm going to simplify the top to be positive 2.
But yeah, but just multiply the 1/2 by 2.
Oh yeah, 2 times a. You're right. So we don't even need that.
Yeah, 2 is cancel out to
What's 2 times 1/2?
1.
1. So this would be 2 over 1, which is 2. Even better. In the denominator, it's 2 times a. So it's 2 times 1/2. I forgot the 2. When you multiply, this would be 2 over 2, which is just 1. All right, so the first number in our vertex is 2. How do we find the second number? Plug it back in. I'm going to plug it into the x's. So I have 1/2 times 2 squared minus 2 times 2 minus 1. So 2 squared is 4. So we have 1/2 times 4 minus 2 times 2 would be 4 minus 1. What is 1/2 times 4? 2, perfect. It would be 4 over 2, which simplifies to 2. What's 2 minus 4? Negative 2 minus 1? Negative 3. So our k is negative 3. So our minimum value is whatever the k is, negative 3. Now let's find our domain. All real numbers. Domain is always all real numbers. I'm going to say ARN to abbreviate.
How do you determine whether you're going to find the minimum and the maximum?
It depends if your graph opens up or opens down. So here, since our...
If it opens up, you find the maximum.
If it opens up, you're finding the minimum because the vertex is at the lowest point. If it opens down, your vertex is at the highest point, so that would be a max.
How could you tell if it's opening up or closing?
The A.
So if it's like less than
If A is positive, it opens up. So if A is positive, it opens up. If A is negative, it opens down. All right, now let's find our range. So range, we say y. Do you think the y values are going to be greater than negative 3 or less than negative 3? Is our graph pointing to big numbers or small numbers? Bigger numbers. It's going up. So we're talking about y values that are greater than or equal to negative 3.
So if it went up, it'd be greater than, and if it went down, it'd be less than.
Now we're not going to ask you about increasing and decreasing on the test or quiz, but the homework asks for it just because it's going to ask for all of this in one question. So we're decreasing on the left side. So we'd say decreasing left and increasing right. So the homework, it's just you just put left or right. But we're not gonna ask you about that on the test or quiz. All right, let's look at A. In number 5, we're gonna do A. So this one. All right, so first thing we wanna know, is our graph gonna open up or open down? How do we know? Because A is positive. What's our A? 4. What's our B? And C? Negative 3. So our graph is going to open up. Does that mean that the vertex is at the highest point of the graph or the lowest point? Lowest. So do we have a max or min? A minimum value. We've got a minimum. Now our minimum is the K. How do we find K? I have to find the vertex. So let's find our vertex. Our vertex is negative b over 2a. So it'd be negative 16 over 2 times 4. So negative 16 over 8. So this simplifies to negative 2. So the first number in my vertex is negative 2. Is that my k? No. How do I find k? Plug it in. Got to plug it into the x's. So 4 times negative 2 squared plus 16 times negative 2 minus 3. So negative 2 squared is 4, and 4 times 4? 16. What's 16 times negative 2? Negative 32. So we have 16 minus 32 minus 3. What's 16 minus 32? Negative 16. And negative 16 minus 3? Negative 19. So what's my K? Negative 19. So what's my minimum value? Negative 19. Let's find the domain. What's our domain? All real numbers. It is always all real numbers. When I ask you that on a test or quiz, it's going to be like a free question. No math required for domain. Just got to know it's all real numbers. Now let's find our range. Our range is y. It's either greater than or equal to or less than or equal to whatever our k is, which is negative 19. How do we know that it's greater than? Because our graph is pointing up. It's pointing up to positive numbers, so y is going to be greater than or equal to negative 19. All right, so in addition to vertex form and standard form, we also have intercept form. Intercept form, I would say, is the easiest because your function is going to be written like this, where we have two parentheses. The number that we are subtracting from x, we always flip the sign, but those are going to be our x-intercepts. So our graph is going to cross the x-axis at, here it says P and Q. So those are our x-intercepts. Cody.
All this is like one lesson.
Mm-hmm. And then, yeah. And then to find our axis of symmetry, we use x is equal to P plus Q divided by 2. All right, so example 4. We want to find the x-intercepts of our graph. So our x-intercepts are whatever we're adding inside the parentheses. We just flip the signs. So our x-intercepts are going to be what? Negative 3 and positive 1. So on my graph, I'm going to cross the x-axis at negative 3 and positive 1. Yes.
It's not plus 3?
Change the signs. If it's in parentheses, change the signs. Just like how we change the sign for our H because it's in parentheses. Change the signs. All right, next, how do we find the axis of symmetry? P plus Q over 2. So we add the two numbers together and divide by 2. So negative 3 plus 1 over 2. We're finding the well, I guess the average, but the middle of them. It's going to fall right in between them. So this would be negative 2 over 2, which simplifies to negative 1. So my axis of symmetry is going to go right through negative 1. So it's x is equal to negative 1. All right, so my vertex. What do you think the first number in my vertex is? Negative 1, same as our axis of symmetry. Now here's the hard part. How do you think I find k? Plug it in. Awesome. Same way that we did before. We plug it into the x's in the original equation. So I have negative 2 times negative 1 plus 3 and negative 1 minus 1. So this will be negative 2 times negative 2. What's negative 2 times 2? And negative 4 times negative 2? Positive 8. So my vertex is at negative 1, positive 8. So I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. That would be my vertex, and I connect the dots. So let's look at 6. So first we want to find our x-intercepts. What are the x-intercepts here? Cody? -1 and? -5. Flip the signs of both of them. You have to switch both of them. Both of them. They're both in parentheses, so you switch the signs of both of them. So let's go to our graph. We're going to cross the x-axis at -1 and -5. How do I find the axis of symmetry? P plus Q over 2. Add them together and divide by 2. So -1 plus -5 over 2. So we get -6 over 2, which is -3. So my axis of symmetry is going to go right through -3. All right, next we want to find the vertex. What's the first number in my vertex going to be? -3. Same as our axis of symmetry. How do I find the second number in the vertex? Plug it in. We plug it into the x's. So I have negative times -3 plus 1 times -3 plus 5. So it'll be negative times -2 times +2. So that turns into +2 times 2, which is 4. So my vertex, I'm going to go to the left 3 and up 4.
Please report student services. Mia Martinez, please report student services.